Math 2, Unit 8, Worksheet 1, Properties of Exponents. Let's go over just a couple of examples of exponents right now. First of all, when we are adding the same base, for instance, if we're adding x squared plus x squared, what do we get when we add x squared plus x squared?
2x to the 4th.
No. 2x squared. These are like terms, so we can add them and we get 2x squared. If you have an x squared and I have an x squared, together we have 2x squared. Combining like terms. You do not change the exponents. Now, when we're multiplying x squared times x squared, now when we multiply the same base, we add exponents, right? So that is x to the 4th. Is everybody clear on that? Okay? Combining like terms versus versus multiplying the same base, we add exponents. Is everybody good there? Okay, I'll take that as a yes. Now, if we have, let's say, x to the 5th divided by x to the 3rd, in this case, when we divide the same base, we subtract exponents. Do you remember that? So that would mean x to the 5th divided by x to the 3rd is really x to the 5 minus 3, or x squared. Is everybody good with that? Okay, and in Math 1, I write it all out in expanded notation. I cancel x's. I'm hoping in Math 2 we don't have to do that. Do we feel confident with this right here?
Yes.
Okay? So then what happens, we get this weird example where you get x third divided by x to the 3rd, and that means x to the 3 minus 3, which equals x to the 0, which means what? Anything to the 0 power equals 1. Because remember, anything over itself equals 1, right? A over A is equal to 1. 5 over 5 equals 1. 27 over 27 equals 1. X to the 3rd over x to the 3rd equals 1. And the reason for that is x to the 3rd divided by x to the 3rd is 3 minus 3, x to the 0, which equals 1. Are we good with that? Okay, so the next thing we have to do is when we have x to the 3rd divided by x to the 5th, if we stay with our subtraction rule, we end up with x to the 3rd minus 5, which equals x to the negative 2 power. Well, what does a negative 2 power mean? Basically, what it means is reciprocal. X to the negative 2 power means x squared, the reciprocal of x squared. 1 over x squared. Okay, and the reason for this is, let's take a look at this guy in expanded notation. It's the one I'm going to do in expanded notation. Okay, x to the 3rd divided by x to the 5th is really x times x times x over x times x times x times x times x, right? This is basically this when we write it in expanded notation, correct? Yes? And then we think about reducing or canceling. What's left on top?
Nothing.
Well, we don't want to say nothing. Just a 1 is left on top, right? Because remember, every variable has a coefficient. So this is really ends up being 1 times 1 times 1, or 1. And what's left on bottom? X squared. So you can see that when you use subtraction method or you use expanded notation, they both end up being 1 over x squared. Okay? So that's the really important thing to walk away from. A lot of people struggle with is negative exponents mean reciprocal. Okay, a couple of examples of that is, for instance, if we had 3 halves to the negative 2 power, think reciprocal. This guy actually equals 2/3 to the 2nd power, or 4/9. Okay? What does negative 3 x to the negative 2 over y to the negative 3 equal? Okay, well, we have to think of it like this. The negative 3 is really to the first power, isn't it? So it stays right where it is. X to the negative 2, we already know goes on the bottom, doesn't it? Because the reciprocal of x squared is 1 over x squared. Now, this one's a little tougher for you guys. The reciprocal of y to the negative 3 is 1 over y to the third. But since it's on the bottom, it ends up on the top. How many of you guys remember that from last year? Okay, I literally taught this to my Math 1 class yesterday. And to be honest with you, they didn't do a very good job with it, so I retaught it today. So you guys, a lot of you may not have remembered it very well from last year, to be honest. Okay? So let's do an example over here. We'll do one more example. I'm going to give you kind of a tricky one and see if you can come up with the answer here. So it might be something like, let's go 2x to the negative 2, y squared, z to the negative 3. Okay, see if you guys can simplify that guy. So start on top, leave the things that need to stay on top there. If they have a negative exponent, move it to the bottom and make the exponent positive. Then work to the bottom. If the bottom has something that should stay, leave it there. If it has a negative exponent, put it to the top and make that exponent positive, and then combine like terms. Okay, so let's work through this. When I'm solving these, I start on the top and I work my way from left to right. The only thing that's going to move is a negative exponent. Now, right off the bat, here's a mistake everybody makes. They think that negative sign means it's supposed to go somewhere. But that's not a negative exponent. A negative sign doesn't change anything. So the negative 2 is going to stay on top where it belongs. X to the negative 2 is going to go to the bottom and become x squared. The y to the second is going to stay right where it is. The z to the negative 3 is going to go to the bottom and become positive. Everybody with me so far? Okay, now I go to the bottom. Y to the negative 3 goes to the top and becomes positive. Z squared stays on the bottom. And now my last step is to combine like terms. Negative 2 y to the 5th over x squared z to the 5th. Oh yeah, sorry. Sorry about that. That's why you got to cross your z's. Well, if you thought it was a 2, then you should have came up with negative 16 y to the 5th z squared over x squared z squared. If this was a 2, right? Oh, no, it would have went at the bottom. I'm sorry. No, it would have went at the bottom. Became 8. So you should have got, then it would have been negative y to the 5th over 4x squared z squared? Yeah? Anybody? Are you with me on this? I mean, if you thought that was a 2, it should have went to the bottom, became positive 2 to the third, or 2 times 2 times 2 is 8, so you should have got negative 4 over 8, negative 2 over 8, which is negative 1/4. Are you dumbfounded or what? There's a lot of quietness today. I don't know. Did you get the same answer?
I got the same answer as you.
Okay, well then, yeah. I mean, there's different ways to manipulate and move things around. Okay? That's just what I think is the easiest way, but, you know, you could, bring these up and get 5 right away. All right, then let's go ahead and do some problems here, and let's just get right into it. All right, so expand and evaluate. So 4 to the third means what? 4 times itself 3 times. So 4 times 4 is 16. 16 times 4 is 64. Good job.
Thank you.
Okay. Well, let's go over and look at 3. 3 is 3 times itself 4 times. So 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Easy enough, right? Okay. Let's go down and take a look at 4 through 6. Rewrite each expression using only one base. You do not need to work out the final answer. Well, that's good. Well, when we are multiplying the same base, what do we do? What do we do? Add exponents. Okay? So I'll do this one. I come up with 11 to the 7th. You guys agree with me? Okay, usually you guys forget that this is to the first power, isn't it? I think you should be able to do 6 and 4. Remember, be careful with those negative exponents. Okay? All right, let's go down to 7 through 21. All right, a lot of these are the same. Simplify each expression. So when we're multiplying, you simply multiply the coefficients, and if it's the same base, you add, or the same variable, you add their exponents, right? For instance, 7 times 3 is 21a to the 6th. How are we doing on that? Okay. I want to take a look at, we'll get to 14. Let's see. All right, in 7 through 12, I'll do one more. Which one do you want me to do?
A negative 1.
I'll do 12. How about that? Oh, let's.
8 through 12. I mean,
8.
9?
8,
9? Oh, that's 12 or 11 is the one I do. Which one do you want me to
You
do?
could do like
12.
you could do all of them to give us a better example.
12. Okay. 12. 6 times negative 4 is negative 24. P squared times P squared is P to the 4th. Q to the 1st times Q to the 4th is Q to the 5th. Easy peasy. Just be careful here. What's M to the 5th times M to the negative 3?
That was a little easy. Can you do a more challenging one? You do like number 11.
Yeah, well, no, that's the one I was talking about.
Okay, try number 8. Try number 8.
You guys are so lazy.
8 is 15.
I'll do 14. Oh, well, let's do this one. So does anybody know what this one is?
I wonder what it is.
Well, tell me. What is number 13?
8 to the 8.
A to the 8th. Does everybody know that and feel comfortable with it?
Yes.
When you raise a power to a power, you multiply the exponents. Right? Gentlemen? Yes? Oh. I know, but you know what? He's, a Math 2 sophomore, and I'm a highly paid, highly trained professional math teacher.
For 13, do you do 2 to the 4th?
What? You what?
You do 2 to the 4th and x to the 4th.
Yes. Okay. So, when you raise a power to a power, you multiply, right? So, negative 1 times negative 3 is k to the 3rd. Okay, so let me show you why this works, though. Let me show you in our kind of our long way. Because in parentheses, negative exponent means it's reciprocal, right? So the reciprocal of k to the first would be, you'd put it on the bottom, right? And then make it positive. So you end up with 1 to the third, which is 1. K, negative 1 times 3 is k to the negative 3. But what does a negative exponent tell you to do? Put it up top. So that's why that works out that way. It's basically the reciprocal of a reciprocal. Ooh, whoa.
We should do fish.
Okay, this one, remember, is 2 to the 4th x to the 4th. I hope I had your attention.
Equal 11.
So when we have Scott. Okay, we are at the beginning of the semester, so I want to remind you of something I told you at the very beginning of the year. And it happened a lot in December. In June, a lot of you are going to be coming to me and say, Mr. Zimmer, what can I do to bring up my grade? And what I'm going to say is, Scott, go back in time to January 9th and pay attention to me instead of what's going on behind you. Okay? All right. So 2x to the 4th is 2 to the 4th, x to the 4th. 2 times 2 is 4 times 2 is 8 times 2 is 16x to the 4th. Okay? Any questions on the front page? Oh boy.
Do you just add these, or do you add these or multiply them?
Same base. When you're multiplying the same base, add exponents. Yes.
If you're distributing and or like
Where are you at?
number 11.
Oh, you guys are going to make me do 11, aren't you? Okay, let's go do 11. We are multiplying. So this is really so 12 times 1 is 12, right? M to the 5th times m to the negative 3. Same base, add exponents. 5 plus negative 3 is m squared. N to the 5th just comes along. Now, why does that work? Because m to the 5th times m to the negative 3 is really m to the 5th over m to the positive 3, isn't it? And 5 minus 3 is 2. Do you understand how that works? Okay? What's so great about math is the rules never change on you. All right, back page. I've already done most of the front page for you. All right, 16 through 21. I'll do one of those for you, and only one. Which one? 20? Okay, good one. That's probably the best one. So look at, this is order of operations, guys. We are multiplying these two together. But before we do it, we have to raise this guy to the exponent, right? So here's how we do this. The 4jk squared is going to stay right there. 2 to the 3rd power is 2 times 2 times 2, or 8, right? 2 to the 3rd power is 8. J to the 4th raised to the 3rd is j to the 3 times 4 is 12. Okay, so we've taken care of this guy. Now 4 times 8 is 32. J to the 1st times j to the 12th is j to the 13th. K to the 4th. What do I, second, sorry, second. How do we do on that? Okay, moving on. Ooh. 22 to 30. I'll do 2 of those. You guys choose. 27 and 23. They're all pretty easy. All right, 27 and 24?
Yeah.
That's easy.
Okay, they're
And
all.
do 27 and 30.
Okay, 27 and 30? All right, 27 and 30 is simplify each expression, write the final answer using only positive integers. Okay, so 27. First, I'm going to distribute this 1/3 to everything on the inside. So it becomes x raised to the third is x to the third, y to the 21st, over 3 times 5, x to the 15th, y to the 9th. Okay? And then I simply, I can subtract. From here, what I would do is say, hey, listen, I'm going to take 3 x's off the top, which means I have to take 3 off the bottom, right? Which leaves 12 x's on the bottom. I got 21 y's on top and 9 y's on the bottom. I'm going to take 9 y's off the bottom. And if I take 9 y's off the top, I'm left with y to the 12th. Does that make sense? Okay, there's always more than one way to do it. You could have went 3 minus 15 is x to the negative 12. 21 minus 9 is y to the 12th. And you could have got this answer here. But what does it tell you up here? Only positive integers. So you would have changed this guy to y to the 12th over x to the 12th. Are you guys following this? Please speak up if you're not. These are all just different techniques to solving these problems. Okay, and finally, number 30, you guys said? That's another good one because real simple. This is actually a simple one, but it's probably the toughest one here. So, negative 3, guys, negative 3 is to the first power, so it's going to stay right there. But your x to the negative 2 goes to the bottom and becomes positive. That's all there is to it.
Wait.
Yes. Sure. You don't want to stay for the end of my stunning lecture?
No, I'll see you.
Okay. All right, 31 or 32. Which one do you want me to do? I'll do one. 32. Okay, sure. Always pick the bigger number because it's got to be harder. Okay, is x to the 4th times x to the 3rd equal to x to the 4 raised to the 3rd? What do you guys think?
No, because when you add,
No.
Very good, because x to the 4 times x to the 3rd is x to the 7th. X to the 4th raised to the 3rd is x to the 12th. So the answer is no. Pick the values for x. Let's see. Pick values for x to show your answer is correct. I did that. Easy peasy. Any questions?